So my name is Roderick Stewart. I work at Montserrat Volcano Observatory. I have worked at Seismic Research Centre for 15 years now, and I've worked at various islands in the Caribbean. So I've got quite a lot of experience of what we're talking about. So plate tectonics is the sort of cause behind earthquakes and tsunamis. The world is split up into, I think it's 7 tectonic plates, large ones, a number of small ones. The Caribbean plate is one of the smaller ones. The earthquakes happen basically around the margins between these plates. We also have volcanoes that happen at the margin between these plates. The plates are slowly moving around on the Earth's surface, rubbing up against each other, and the friction that runs between them is the cause of earthquakes, and the melting of the material is the cause of volcanoes, hence the ring of fire in the Pacific Ocean.
Yes.
Yeah, okay, that's good. So this is a diagram of the Caribbean plate. Basically, the Atlantic plate is pushing westwards, and the Caribbean plate, which goes from Central America over to ourselves, is moving eastwards relative to that. So they're moving towards each other. On the north and south margins, the plates are basically moving side by side. So we don't get volcanoes there, we get a different type of earthquake. And on the Pacific margin is another place where we think the plates are moving together. So we get sort of subduction zone earthquakes. But basically, where we are, the Lesser Antilles and Barbados, we have 2 plates that are pushing into each other. And we get this. Basically, the North American plate is going down underneath the Caribbean plate. It is then melting the rock and it's punching up through the Caribbean plate to form a chain of volcanoes. And we have volcanoes, basically every island from Saba in the north here, down to St. Vincent and down to Grenada, are volcanic islands. I'll just make it slightly smaller. That's better. And all these red triangles are the volcanoes. Dominica is the worst country. I think there's 7 potentially active volcanoes there. So this is a chain of volcanoes caused by plate tectonics. Very interestingly, this sort of line of islands, the black ones going up here, they're all old volcanoes. The chain used to go up here, and I think it swapped over to this side about 5 or 10 million years ago. And then these islands like Antigua, Anguilla, half of Guadeloupe, basically with erosion, they've moved down and the volcanoes become buried with coral, basically, coral which then turns into limestone. So all these islands are volcano-based. The only island that's not volcano-based is Barbados. Now, what happens then is when you have a plate that's running here and it's running down underneath the other plate, the volcanoes are here, you get a sort of buildup of material where the plates are. Basically, it's being scraped off the top of the subducted plate, and it's called an accretionary prism. And you get lots of complicated thrusts and wedges, and the scientists have got lots of different names for these. But basically, it builds up land, and then some of it just punches through, gets up above sea level. And that's the case in Barbados. Barbados here. This is the subduction zone here. And this is a very large accretionary prism. And there's like a fold that runs north to south around here. And Barbados is just one of the points on that fold. So your island is generated by the plate tectonics, but not in the way that the rest of the islands are. So these are the sort of large earthquakes that occur in the Caribbean, and they basically follow the plate margins. We can see many, many earthquakes over on the west coast of Central America. We see earthquakes at the north, sort of where we're slipping by each other for Jamaica and, pardon me, Dominican Republic, Haiti, etc. Same at the south of Venezuela. But then here we have this arc of earthquakes associated with the subducting plates. When we look at a map of these earthquakes closely, on the left we have the shallow earthquakes, these white ones. If you look at the deeper ones, and they go down to about 300 kilometers in depth, The green ones are the shallowest, the yellow ones are the next shallowest, and the red ones are more than 100 kilometers. And so you can see that the earthquakes get deeper as you go further west, and that's because they're tracking the subducted plate. Now, when we measure earthquakes, we often use earthquake magnitudes. This is often referred to, especially in the press and the public, as the Richter scale. It's not the Richter scale. The Richter scale is a type of magnitude, but you can call it a Richter scale if you want to, but it's magnitude. And we measure it from the size of the waves that we record. So it's an actual scientific measurement, and it does not depend on the distance that you are from the earthquake. So it's something that could be used to compare earthquakes. It's a logarithmic scale, which means that a 6 is 10 times larger than a 5, a 7 is 10 times larger than a 6, and an 8 is 10 times larger than a 7. It's open-ended. In theory, you can have earthquakes with negative magnitudes, and people, if you just like compress a bit of concrete, you'll have tiny little earthquakes in it, and they'll probably be magnitude -3. The upper end of the scale is limited basically by the size of the Earth. If the Earth split in two, that would be possibly the biggest earthquake we could have. But the largest known in our sort of current configuration is probably magnitude 9.2. But this occurred before instruments were recording things very well. So that's an approximation. That's not an exact number. But magnitude is what we use to scientifically measure the size of an earthquake, and we can use it to compare things. The other scale we use is called the modified Mercalli scale. It measures intensity. And this is not open-ended. It just goes from 1 to 12. And we use Roman numerals to try and distinguish it from magnitude. And it really just describes the amount of shaking that is encountered from the earthquake. So 11 and 12 are basically extreme cataclysmic, the total destruction, and 1 is basically hardly felt at all. This is a useful scale that we can use for zoning, where people feel things and stuff. And it's the only scale we can use for earthquakes that occurred over maybe 50 years ago, 100 years ago, when we started putting out instrumentation. So it's a very important scale to use, but it is very different from the magnitude scale. What actually is an earthquake? We talked about these plates pushing up against each other, and in this diagram in the top left, basically the red line is a fault, and it's all relaxed. It's got rock either side. And over the years, those two rocks are trying to move relative to each other, but the fault is locked. So the whole rock mass becomes stressed. And so over many years, the rock mass is gradually becoming stressed and becoming deformed. And the more stressed and the more deformed it is, the bigger the eventual earthquake will be. And then suddenly you get slip on that fault. The stress becomes too much, and bang, it is released in a very short period of time. And that is what causes the earthquake. And you can see in the photograph in the bottom right, this is actually a surface fault in California that has actually run through an orchard of some time. And you can actually see the line of the fault there that all slipped in one sort of, it's not instantaneous, but it'd be less than a few minutes sort of thing. So the stress builds up, and the more stress builds up, the bigger earthquakes you can have. This is just a list I got from Wikipedia. These are the most catastrophic earthquakes of the 21st century since the year 2000. And at number 2 in that is the 2010 Haiti earthquake, an earthquake in our region. I think the official death toll, actually, the death toll is quite disputed in this one. 160,000 is what people feel is a good estimate, but the estimates, some of them are above 300,000. But the thing is, it is incredibly devastating. It causes a huge loss of life. I think the record over all of history is up in the millions for some earthquakes in China, but really it causes a lot of problems. You can see that the worst earthquake of this century is the Indian Ocean earthquake, which also generated a tsunami and caused devastation over a much wider area. But these are serious things that we have to worry about. and we have to be prepared for. So what sort of affects the damage that's done by an earthquake? It's affected by two things. The first is the amount of shaking. Actually, I'm going to go back a slide. One thing to notice from this is that the Haiti earthquake was magnitude 7, whereas Indonesian earthquake was magnitude 9.1 to 9.2. And most of the other earthquakes in this list are 8 and above. It's not just the magnitude that causes the problems, it's where you are. The Haiti earthquake was located almost directly underneath the capital, Port-au-Prince, and it was very shallow. And that's why it caused so much shaking. So this is what really causes the shaking. It's a combination of the magnitude of the earthquake, the distance between where you are and the hypocenter, that's the location of the earthquake, and the depth of the earthquake. The deep ones in this region, which are 300 kilometers deep, they can cause shaking, they can cause damage, but they're not going to cause the amount of shaking that the same size, the same magnitude earthquake would cause if it was very shallow. The other contributor, and this is very important, are site effects. The type of rocks beneath the site where you are greatly affects the amount of shaking that you can get. And that's something that needs to be studied and needs to be used for zoning for dangers. Also, the type of buildings that are there, some are more prone to be damaged by earthquakes than others. And finally, the quality of construction. Poorly built buildings, which are not up to code, are going to be affected much worse by earthquakes than buildings that follow the building codes. So that's the sort of things that cause damage. I have many photographs of damage, but I don't want to show them all. This is from Haiti. And basically that earthquake caused total damage in the capital and the surrounding areas. The building stock was very poor quality and catastrophic effects. That's the sort of shaking that you had. Here's another even worse thing that can happen. This is called liquefaction. If the shaking is really large, and the soil that you're sort of built on, or the rocks that you're built on, are quite soft and malleable, they can sometimes liquidize. Maybe if there's water there and it's on soft ground, the subsoil can actually turn to liquid. And you can see in the top left photo, these are apartment blocks in Japan that have just fallen over. Their foundations have disappeared. The apartment blocks weren't damaged, but they just fell over because of this effect of liquefaction. Liquefaction is known in this region. It's not massive, but it's been seen in Trinidad with some of the big earthquakes. And the photograph in the bottom right is the wharf in Haiti in the 2010 earthquake. And we think that was damaged by liquefaction. It lost its foundations, and that's what caused all the subsidence you can see there. So liquefaction is like the extreme end of really intense shaking combined with very poor ground conditions where you build. The other effects can appear much smaller, but they can be still very threatening to life. I think these are from a Martinique earthquake. The picture on the left, I believe, was taken in Barbados. The picture on the right, it was in Martinique. Does not look so catastrophic to begin with, but if you notice, there's lots of things that have sort of fallen down from the ceiling. Light fitments, air conditioning, panels, things like this. So if you're inside a building, even though the building doesn't totally collapse, there's a serious hazard from these things falling on top of you, and that can cause a lot of injury. So we have to be sort of careful of intense shaking, but also the smaller shaking that you can get from, that can cause problems. I once experienced an earthquake where the shaking wasn't too bad, but when I got home, in my kitchen, every single tin can that was in my cupboards was on the floor because they'd been shaken out of the cupboards, So it's something that can affect us and we need to be wary of. There are also secondary sort of hazards when you have a large earthquake. Landslides, which are going to cause, they can damage buildings, houses. They're going to be blocking roads as well. Fires quite easily break out, whether it's gas supplies being disrupted or other things. The entire emergency system might be disrupted or overwhelmed. The hospitals, the fire service, the police, they can't get to everyone very, very at the same time. And then you start having problems with if you've had a major earthquake with shelter of people, providing water to them, and disease, because these places are very unhygienic if people are living in emergency shelters. And some of the major sort of fatalities in earthquakes, including Haiti, a lot of those fatalities were caused by the problems after the earthquake, with disease and shelter and not good water. The other thing that is a problem, and I forgot to make a slide about it, is the aftershocks. When you have a large earthquake, you will get smaller aftershocks afterwards. And this can go on for days or even weeks. Now, even though these are smaller, they could still be hazardous because buildings that have been weakened by the earthquake may just fall when another small earthquake comes along. So you can't just push people back into all the buildings if there's been a major earthquake. You need to keep them out, and you need to check building sort of integrity to make sure that they're usable again. So lots of things that have to be done and are problematic during a major earthquake. If we look at the sort of likelihoods in the Caribbean, these are based on statistics collected at SRC. I mean, we have 1,200 earthquakes greater than magnitude 2 every year, but magnitude 2 is tiny. I mean, we have lots of them. We would expect maybe 3 earthquakes, magnitude 5 or more every year, and that's about the size for it will be felt. A magnitude 6 earthquake, you would get maybe every 3 to 5 years. And then in the last 200 years, we've had an average magnitude 7 every 20 to 30 years. And a magnitude 8, we would expect to be every 100 years. So those are not, you know, it's not imminent you're going to get big earthquakes, but it's an area that can get big earthquakes. They can cause lots of damage, as we've seen, and it is something that we have to prepare for. Now, my colleagues in Trinidad told me about some recent earthquakes in Barbados, but this peak actually was in 2015, so I'm not sure if anything's happened since then. There was a little sort of increase in earthquake activity around Barbados around 2015, but that to me is nothing to be concerned about. It's just part of the sort of randomness of earthquakes. Things that are meant to be essentially random in nature, and we could call the earthquake pattern in the Caribbean random, except it has to be where the plate is. But it doesn't look random to the eye. It's like the stars in the sky. They don't look random. They form constellations. They form little groups. So we get little groups in space. We also get little groups in time. So little sort of increases and decreases in earthquake activity, to me, are not something that should cause concern. I don't think they change the likelihood of a large earthquake. I think the hazard from large earthquakes is the same over time, even if you're getting more nearby earthquakes. So we should really sort of, well, not forget about them. It's important for us to study them because they might show something, but what we've seen so far is really there's nothing particular happening around Barbados, and we should be preparing for these big events, as should the rest of the Caribbean. Now, Barbados is slightly blessed. We are away from the main earthquake zone a little bit, and this is just a summary of the felt intensity. That's the sort of devastation scale over the 400 years from 1500 in the different islands. And Barbados, which is second from bottom, has only ever had intensity 6, never gone above that. It's only happened 4 times, where Haiti, twice it's been intensity 10. North Lesser Antilles, again, intensity 10. Other islands, being nearer the earthquakes, are getting more shaking, whereas Barbados gets less shaking than the other islands, but it is still a hazard and a problem. These are some of the sort of historical examples of reports of these earthquakes in the past, going back to 1690. The 1690 earthquake, I note this is from the Colonial Records Office, did no manner of hurt to men or cattle. They compared a lot, they cared about their cattle in those days. But there are reports here from these earthquakes about damage to buildings in Barbados, houses in Broad Street. You can scan through these. I'm not going to read them, but we've had earthquakes that cause damage, and so the potential is there. The most recent one I've got a report from is 1953. Damage to government property estimated to be $200,000. That's not a lot, but those days I'm not sure how much it was. But a major earthquake is causing many, many millions of dollars worth of activity. But, you know, so Barbados does get affected and has the potential to be affected. Oh, yes. Can we predict earthquakes? No, we can't predict earthquakes. When I started out as a scientist, and it's a long time ago now, there was a lot of confidence in seismology that predicting earthquakes is just around the corner. No one talks about it anymore. It's really one of these things. I'd liken it to the parable, the straw that breaks a camel's back. You put all these straws on the top of a camel, and it will eventually crumble, but you can't tell which piece of straw actually causes it to crumble. And this is the problem. The stress is slowly building up underneath our feet, but we cannot tell when or where it reaches that sort of trigger level to cause an earthquake. So we cannot predict them. We can tell you where they're going to be. We can talk about the depths, we can talk about the shaking, but we cannot say there's going to be an earthquake tomorrow. And don't believe anyone that says you can. So what do we do? We need to build earthquake resilient buildings, okay? We need to build structures and buildings that can survive the shaking that we expect. And very important in that is using building codes properly, okay? Buildings should be built to code, because if you try and retrofit a building that wasn't built to code, it is very, very expensive, because, you know, the building codes require certain foundations, they require strong, often they require diagonal sort of strengthening elements in the building. Very, very expensive to retrofit. So it's very important to have buildings that are resilient. We also need to have earthquake hazard maps. We need to identify how much the hazard is, how much shaking you might expect, because that then drives what building codes you use. And we often use a thing called microzonation, which is where we identify areas where ground movement might be larger. Say the soil we think is prone to liquefaction, that could be highlighted in advance of any earthquake so that the building codes in that area would be stronger than maybe in other areas. And this has been done for Barbados. This is a series of maps that basically give the probabilities of shaking of a certain amount at different locations in Barbados. And you can see your island is mainly stripy. It's different from the east and the west. This is a study carried out by SRC and has been published. I don't really understand it much. It's not my type of science, but it's useful to the builders and people doing that. But we'll just look at one map. This is the maximum peak ground acceleration in G. G is the force of gravity every 2,475 years. This is the real extreme. This is the worst you'll ever get. And you can see that it's greater in the northeast of Barbados, sorry, the northwest, than it is in the southeast. However, if you look at the numbers, they're all above 0.4 G. Okay, it's not really a big span. So the whole island would be shaken roughly the same. And 0.4 G is a massive amount of shaking. That's half the force of gravity. If it was 1 G, you would actually be thrown up in the air. Buildings are normally built, a good earthquake resilient building is built to withstand maybe 0.25 G, not 0.4. So it's sort of encouraging that we're not going to get those sorts of shakings for quite a long period. SRC have actually also done a seismic hazard assessment for Bridgetown itself. And this is a published paper done by one of my colleagues at SRC. And this is one of the graphs in it. And this shows the sort, again, the bottom line is the acceleration, and the y-axis is how often it occurs. So down at the bottom right, where you've got an acceleration, it's a logarithmic scale, so that's 1 to 3G. That would be expected once every 10 to the power 5 years, which is once every 100,000 years, okay? But 0.1 G, just let me get my cursor here, 0.1 G, put it up there, put it across there. Yeah, that's roughly every 100 years, 0.01, that's every 100 years. So you get 0.1 G every 100 years on average. 0.2 G, which is what buildings should be done to, between, that's about every 500 years sort of thing. So it agrees with the numbers that I was talking about. But these charts are very useful for the people that are implementing building codes and warning systems and things like that. So SRC has done all the background work for this sort of stuff and continues to do it. It's an active area of research at SRC. But other things that we can do at home or in the office, you should earthquake-proof your surroundings. You should not have heavy things on top of tall cupboards. You know, that's just asking for something to go wrong. Similarly, my tin cans in my cupboards, they shouldn't have been on a wall-mounted cupboard. They should have been on a floor-mounted cupboard, so they're not doing out and damage you. Securing things like gas canisters, water tanks, heavy things, but basically anything that can be an upside-down pendulum can be seriously affected by an earthquake. So you can make efforts to earthquake-proof your surroundings, and then you can have an earthquake preparedness kit. You can actually have things, and we'll talk about this later, that you can use to prepare for when you're affected by an earthquake. And finally, education. The most important thing is to educate people to make sure they know what to do when an earthquake occurs. And it's very simple. You do the DCH, drop, cover, hold on. When you feel the shaking, do not try and run outside. Do not try and stand under a doorway. Don't look up the triangle of life thing. The best way to do things is to drop, get under a table or anything else, and then hold on and wait until the shaking stops. Then afterwards, and this is down to your own judgment, to deem it safe to leave the building and go to some sort of muster point where then people can take over. And we have a photo here of some school children practicing this. The best way to disseminate this sort of information is through the schools. I have very strong memories. When I first arrived in Trinidad, we had a felt earthquake, and all the kids in one class all got under their desks, and their teacher was shouting at them, saying, "What are you doing? Come on, get outside." And the kids knew what to do, the teacher didn't. So we get through the kids and make sure they sort of teach their parents. But everyone should know to drop, cover, hold on. If there's nothing to go underneath, you can still drop and cover. As I said, if you're in a room, you're in a classroom, there are dangers of just things falling from the ceiling or things falling from the head. And just taking your school book or a telephone book could help protect your head if there's nothing else that you can get to cover underneath. And this is a personal peeve I've got. Everywhere I go, hotels, public buildings, things, inside the doors, there's always a fire notice. There should be an earthquake notice that just tells people, drop, cover, hold on, and then maybe gives the muster point to go to afterwards. And I don't know why this isn't done. I've never seen this. I asked some people once, hoteliers told me that, oh, it might scare people away, but it doesn't. A fire notice doesn't scare people away. And I just think it's a no-brainer, putting notices in public places like this, where if you've got a tourist, they'll see this every day when they leave the room, and so they'll get drop, cover, hold on, punched into their heads. So I think that's something that could be done.